Class, what's up? I hope everyone is doing well. We are moving away from piecewise functions to get to our last topic for this chapter, which is maximizing area. Alright, so before we get started, let's take a look at our learning targets down at the bottom of the next page. Down here, this is what we're going to try and do today, okay? We want to be able to write an equation representing the area of a rectangle, or a square, or a triangle, or a circle. We want to be able to state the domain of an area equation, okay, the domain of an area equation. And we also want to be able to graph an area equation. Now, just keyword here, area equation. That'll make a little more sense in a little bit. Once we have an area equation, we want to be able to find a max or min point using the calculator. We want to be able to clearly label axes to indicate what is represented on this area equation. And then lastly, we want to be able to state the dimensions. Alright, so that is what we are trying to do today. Let's go back to the page before. Alright, up at the top we see some important formulas that you guys should remember from geometry class. These are things that we will be using. Please note we have area of a rectangle. I'll probably more use area equals base times height, but however you like to think about it, it is okay. These are the same actually. Triangles are area 1/2 base times height. Circle area, please be careful and know the difference here. This is area of a circle, this is circumference or around. How do we know that this is area? Because the radius is being squared. It's going to have square units. And then we have semicircles, so just half the area of a circle or half the circumference. Now, one other thing, just for some vocabulary lessons and remembering where some things are located, let's please make sure we remember this is quadrant 1 and 2 and 3, and lastly quadrant 4. Okay, that will be important for kind of figuring out what our pictures are going to look like. So let's jump right into our first example. Alright, this example tells us that we have a rectangle where one corner is in quadrant 1 on the graph of y equals 25 minus x squared, which is plotted for us, okay? So we know that somewhere on this graph is going to be one corner. It doesn't really matter where you put it. I'm going to put it right there, okay? Another is on the origin. Another is on the positive y-axis. Now, if this is going to be a rectangle, we know what's true. Sides have to be congruent to each other. So if I'm going up this distance over here, well, I'm going to have to be right across, kind of like this, for my third point, and then the fourth point, positive x-axis. So along the positive x-axis, I have to create this rectangle. Okay, so now I could sketch in this rectangle that we're going to work with. Alright, if we kind of think about this, well, we know that right here we are at 0, 0. Over here, where are we? Well, we're at 0, y. Over here, we're nice. We're at x, 0. And then lastly, this last point, this is the goofy one. We went over x, and we went up y. But we don't know much about that point yet, okay? So that's all we can really say. This is where we're getting into that learning target of being able to express an area equation, okay? An area equation is using something from up above. Alright, we're talking rectangles here. So we know that we're going to want to use area equals base times height. But, notice, what does it say? I want to write this as a function of x. So we have to use function notation, which means I need to write the area when I plug in a value of x, when I input x. Well, this will equal still base times height, but let's look at our picture. Can we change anything? Where's our base? Where is our base? Our base is right here. Okay, that is our base. And what is the distance, or the length of our base? If we go from 0, 0 to x, 0. My base is x. All right? Thinking the same way, my height, I could draw my height in. My height is right here. My height would just be from 0, 0 to 0, y. Oh, that's y. All right, we're one step closer. Last thing, again, function of x. I'm not allowed, actually, to use this y. If I'm going to be a function of x, then I can only use x's. So I take a look, and hopefully you guys can make the connection that I know that my y value is going to be somewhere on this equation that I already graphed, which had an equation of 25 minus x squared. So what I can actually do, guys, is I can completely replace the y with my y equation. Okay? So that is a skill that I need you guys to be able to see how to do. If you know y is equal to 25 minus x squared, well then you can replace y with that. Now real quick, this again was just my base, and this is my height. Okay? So this is the equation that we are going to be using in a little bit. This is my area equation. Now to find domain, we kind of have to think about, go back to geometry. Remember, in geometry, could you ever have negative lengths? Could you have negative areas? Absolutely not. Same thing here. We know that I can't have a base that's negative. So I know that my base, whatever it is going to have to be bigger than 0. Same thing with height. Why do I care about that? Well, because I know some things. I know that my base is x. So I know that x has to be greater than 0. I know that my height is 25 minus x squared. So 25 minus x squared has to be greater than 0. This is nice. We're done. This, not so nice. We have work to do. Please remember, this is a quadratic inequality. We need to factor. And whenever we factor, it gets us those boundary points, right? So I know I'm going to have negative 5 to 5. And then let's see here. Open circles, right? Because it's greater than, not greater than or equal to. And then let's test a nice point. If we plug in 0, which is right in the middle, 25 minus 0 is greater. Yes, that's true. So I would have to shade in between for my height domain. The last thing we have to do, guys, is you have to combine these two ideas. Like right now, if I were going to write this, I would have to say negative 5 is less than x is less than 5. But, that's just for the height. We also know from the base that x has to be greater than 0. So we need to combine these two ideas or concepts together, which means our domain will have to be sandwiched between what two values? Well, it has to be greater than 0, and it has to be less than 5. So that is my domain. All right, here we go. Now we're going to start graphing. We want to graph our area equation. Our area equation is what we had up here. Okay, this is kind of like y equals on your calculator screen, right? Y equals. So what we're going to do, and if you remember, again, hopefully this makes sense, I only need to plot or graph quadrant 1. Why do I only need quadrant 1? I only need quadrant 1 because I can only have positive areas, and I can only have positive x values for the base. Okay? So this is normal, this is x. This is the goofy part. We're not going to put a y here, right? This is the a of x function. So it's a of x. And then we want to label what these mean. Oh, sorry, I'm a little bit off. We want to label this. Well, we've already been talking about this. A of x stands for the area of the rectangle. How about my x value? My x is the base of the rectangle. Okay? So I label it. Let's see what's going on. Well, we know some things right off the bat which are pretty nice. if my domain is 0 is less than x is less than 5, well then I know already that this would be 0. I could put 5 over here, maybe go 1, 2, 3, 4, right? 1, 2, 3, 4, 5. I can't go past 5. It doesn't work. I already know that from my domain. I don't know yet about the y though. So now we need to grab our calculators, and our calculators are going to help us out. So if you grab your calculator, we need to go to our y equals menu, and we need to plug in our area equation. Okay? This is, again, like y equals, and then this. Don't worry about distributing. Just write it exactly how it is so there's no room for error. Just like that. Next, I'm not going to hit graph just yet. You can, it's not the end of the world, but I want you to go to your window first. Normally, when we were plotting or graphing, we like to use this nice standard window. What I am here to tell you is, you don't need this. We don't need negatives, and we can only have x values as big as 5. So do it. Okay? Min 0, max 5. I'll ask again now when I start thinking about y's. Can I have negative area? No. Put a 0 in there. Can't have negative area. Now the y max, this is going to be the tricky part. You're going to kind of have to play around or guess a little bit for this. So let's start by just saying like, I don't know, 25. Now let's graph and see what we have. No good, right? We need more. We need more. Let's go back to our window. Let's make this maybe 50. Other thing I'm going to do, just to kind of make my labeling a little nicer, I'm going to change my y scale to like 10. Okay? Let's see. Ooh, there we go. We're good now. Okay, this is good. Please keep in mind, remember my scale I changed to 10, so that's 10, 20, 30, 40, 50. So now we can go ahead and we can go back to our paper. And I know I'm going up to 50. Maybe go 10, 20, 30, 40, 50, something like that. And we just kind of sketch it on there. Doesn't have to be perfect. Maybe something like that. Okay? Okay? Cool. All right. We have everything graphed, everything's labeled that we need. We sketch our picture. Now what we need to do is we need to use our calculator to help us out. Remember, this entire section is called maximizing area. Well, what's the max area from my picture, right? If we look at, if we look at this picture, max area means the highest y value or highest a of x value. So my max area is going to be right there. But again, use your technology to help you out. How do we get the max of an equation? We second calc, we use the maximum feature. Okay? So now it says left bound, right bound, and then guess. You guys have options here. A lot of the times I'll just click over and make sure I'm to the left of the max, and then to the right of the max, and then I'll try to guess. Okay? So this gets me kind of what I'm looking for. It gets me my x value, y value. I want to round it though. So let's see here. Let's go 2.89 comma 48.11. All right, so I rounded to 2 decimal places. And here we go. Now this is one thing. I want you to just leave it just how it is. And the reason is because I'm going to need this x value in a little bit. And if I don't move anywhere, and I go back to my home screen, watch this. If I second quit and I hit X, enter, it keeps that X value, okay? So that's what I want you to understand. Once you have your maximum value, do not touch anything because I want to use this in a little bit. All right? Now, let's finish up these questions. For what value of X is the area the largest? Okay, we already know that, right? We wanted the largest area, which is up here, and the x value there is 2.89. We don't have units, so I would just leave it as units. What is the largest area? Well, the largest area is basically the largest y value, or largest a of x value. Well, that's 48.11, and these will be units squared. And now, probably the most difficult part right here. Or I wouldn't say most difficult, but more difficult than this part, obviously. I want the dimensions, all right? Dimensions of a rectangle are base and height. Height. I would argue, and hopefully you guys completely agree, I don't have much work to do for the base. I already know that my x-axis was base of rectangle. So when I'm asking for the dimensions of this largest rectangle right here, I already have the base. 2.89 units. This is the tricky part, okay? And no, I shouldn't even say tricky. You just have to think a little bit outside the box. We have to go back up, and we have to realize that we know the height is going to be 25 minus x squared, right? That's what we wrote. We know the height is going to be 25 minus x squared. So, if I come back down and I do a little bit of work, I know that this is going to be 25 minus, and then I'm going to basically plug this guy in. But again, we have the calculator for a reason. We want to be as exact as possible. So this is where I do not want to just do 25 minus 2.89 squared. Why? That's rounded. We rounded that, and when you square it, it makes everything, it compounds your error. It makes the error even greater. So what we're going to do is we're going to use that feature. We know that x is still 2.88 blah, 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 blah. So 25 minus x squared, 16.67. All right? And that is the dimension of our rectangle. Okay. Let's move on. We have a different shape on the next page. Same concepts, slightly different problem though, okay? Same concepts, slightly different problem. So now, guys, if you notice, this is talking about a right triangle. We're talking about a triangle now. One vertex is on the graph of y equals negative x squared plus 9. Ooh, nothing's graphed. I don't know what this looks like. Yes, we do. This is a upside down parabola, or downwards facing parabola, and it's shifted up 9 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And actually, let me change to black so I have this. And we know growth patterns. We know we're going to go over 1, down 1, over 1, down 3, over 1, down 5. So we do know what this looks like actually. It looks something like, oh gosh, something like that. All right? Now let's see what's going on. We know that one of our points is on this curve, on this equation. So I'll maybe pick, how about right here? Another is at the origin. We know that's right here. And we know that the last one is on the positive x-axis. So remember, if this is going to be a right triangle, please be careful. If it's going to be right, you're going to have to create this perpendicular line. Okay, right here. Now we have a right triangle. Our points are exactly what we thought they would be. This is right here at 0, 0. This is at x, 0. This is at x, y. And just to kind of keep it up, all right, we can shade in so we know what we're looking for. All right, area equation. Well, normally we'd say area equals 1/2 base times height, but again, we want to create an area function, and we want it to be in terms of x. So we're going to go with a of x, and now we have to start replacing things. Well, 1/2 stays. My base, what do you guys think? This is my base. My base is just the distance between the origin and this point. So what is the distance? X. And lastly, I need the height. Same idea, height's going to be right here, which is going to be the distance between x, 0 and x, y. So my height will be y. Now the final thing, and hopefully you guys remember from the page before, and if not, hopefully you guys are kind of picking up on this. I know that based on whatever x value I get, or I choose, I can get a y value by plugging into my original equation. So I have to use that original equation. I know that for some x, y is going to be negative x squared plus 9. Okay? This is what we will use in a little bit. Now just remember, because we'll need it in a little bit, this is our base, this is our height, and now we need to work on domain. Remember, think real world aspects here. Think just like about geometry. You cannot have a base that's less than 0. Actually, you can't even have a base that is 0. Your base has to be greater than 0, and so does your height. So, base is nice and easy. My base was just x, so x is greater than 0. Height, a little bit different. Height is negative x squared plus 9. Negative x squared plus 9 is greater than 0. I don't really like how this is written. I think what I'm going to do is I'm going to change this to 9 minus x squared is greater than 0, because now I see I have a difference of two squares. And I now know that I am going to get a number line, because whenever you have quadratic inequalities, you need to figure out where to shade. So I have negative 3, positive 3. I know they're going to be open circles. Why? Because it's greater than 0. I plug in 0. 9 minus 0 squared. 9 minus 0 is 9. 9 is greater than 0. Okay, so we would shade in between. We know that from the height, I would say my domain is negative 3 is less than x is less than 3. However, for the final domain, you need to incorporate both of these concepts. Domain. I know that x has to be greater than 0. I know that x has to be less than 3. 0 is less than x is less than 3. Okay? Okay. Moving right along, we graph this. We remember area, base, can't ever be negative, so I only care about quadrant 1. This is all my x values. This is going to be my a of x, Similarly to the other problem, x is still just my base value, right? That's what we said above. So this is my base of triangle. And over here, a of x, that's my area equation. It's an area of a triangle, so this is the area of triangle. Now nicely, again, we already know what we can do along the x-axis. My domain is 0 to 3, so this is obviously 0, 1, 2, 3. That's nice and easy. The rest, we have to go back to our calculator, okay? So we're going to take back out our calculator, clear everything. Let's see here. Okay, clear. We have to put in our new area equation. Okay? So, alpha y equals 1/2 x, and then negative x squared plus 9. Let me make sure that 1/2. Good. Okay. Again, you could hit graph. You don't have to, because we know we have to change our window. We know that our x-min and x-max should be 0 to 3. Right? Those are our only possible x values. We know still that we don't want negative area, so we have a 0 for there. Let's go back to like 25 and 5 just to kind of get a picture. Let's see. Ooh. Okay. This is okay. I think I want to see a little bit more. So I'm going to, let's see here. If this was 25, then this was 20, 15, 10. Okay, I'm going to change my window to 10, and then I can change this back to 1 scale. And I'll graph. Alright, this is nicer. This gets me a little bit better of a picture to see what's going on. Alright, so I know that here will be 10, and then I could go like 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Okay, it looks like it's somewhere between 5 and 6. 5 and 6, so maybe that's where I'm going to aim for. Something like this. Now again, the sketch doesn't have to be perfect, but we want it to represent our picture for the most part, okay? Okay, so now, again, we go to our calculator. Remember, we need to get this point. This is the point that's representing the largest area, right? The largest y value in this case is going to be my largest area. So I go to calculate, I use the maximum feature. I go to the left, I go to the right, and I guess, okay, cool. Gets me my point. Please round, please remember to round, so 1.73 and 5.20, okay, 5.20. We round 0.196 up to 0.20. All right, now remember, don't touch anything, right? We want to use this x value in a little bit, so just move it off to the side, and we start answering some questions. Let's see here. For what value of x is the area the largest? Well, again, this picture now represents the largest area. This point right there represents the largest area. So I want to know the largest x value. 1.73. Again, we didn't use units, so we put units. What is the largest area? Again, this point represents the largest area. But you have to remember and make the connection. Area is along the y-axis, so I'm looking for the y value. All right, getting there, almost done. Last thing, dimensions. We need the base of a triangle, we need the height of the triangle. We already know the base. How do we know the base? Because the base is just x. So my base is 1.73. Height, this is where we need to go back to our calculator. If you remember from the very beginning, our height is in terms of x, right? Our height is negative x squared plus 9. Negative x squared plus 9. So what we're going to do is we're going to plug in this base into negative x squared plus 9. Negative x squared plus 9, just so we have it, okay? So we go back to our calculator, and we remember, hopefully, that when we quit out of here, if we don't touch anything, if I hit x, it keeps my x value the same, and that's what I needed. So here we go, negative x squared plus 9. And that gets me my height. Okay, so again, now that we have done a couple of example problems, hopefully you guys understand some of these learning targets a little bit more. I think you guys are probably pretty good at writing an equation based on the area, or representing the area, I should say. Domain, this is a good concept. Again, you have to think geometrically on that. You know that you can't have negative bases and heights. All right, so you have to use some of those concepts. Graphing an area equation. Area equation, before we even get to being able to graph it, remember, area equation is using those geometric concepts, 1/2 base times height, or 1/2 pi r squared. All right, and then figuring out what you have to plug in where. Okay? Once you can graph that and you can plot it and sketch it, well, then you just use the calculator to get a max or min point. In this case, they were maximums. We talked a lot about, or not a lot about, but we talked about clearly labeling the axes, so we really understood what each piece represented. That's important. And then lastly, you can finish the problem up by being able to state the different dimensions. Alright, so I hope that this video made sense. We will be practicing a lot more of these word problems in class. Have a great day.